data handling, summarizing, and representing data. So we want to summarize and represent our data, but we'll dwell more on the summarization of data. We'll summarize a lot. We'll look at what we studied last time when we had our first lesson. So we will consider data handling and the part that deals with the summarizing of the data. At the end of the lesson, you should be able to
define terminology like we did last time, used in summarizing your data. And you should be able to summarize your data collected using measures of central tendency and measures of spread. So we will also look at the analysis and interpretation of the summarized data. Like we said last time, analysis and interpretation of data is done in all the stages of data handling. So today I've added a few words here, terminology that we need to define later, like the quartiles, the interquartile range, and we have all the other measures of central tendency, measures of spread, median, mode, and range, and all the like. You can see those on my screen. Now, I'll move to the first part. We'll actually capture what we did last time on Monday. We will look at how we view measures of central tendency. Measures of central tendency actually are a single value that shows a central position of your data. There are three: mean, median, and mode. So you see the three M's that we have there with the triple M. And we will start with the mean. Now, as you can see, the central tendency, mean, median, mode, those are our three. When you do the mean, commonly called the average, and some people will say, no, it's the arithmetic mean or the arithmetic average. So it's all your sums. So you sum up all your values or all your scores and you divide by the total number of values in your data set. For example, we did this example. I'm going to redo it. We had a learner who had 7 subjects, 70%, 62, 54, up to 58, 7 subjects. And the question was calculate the mean mark. So when you calculated the mean mark, we said the mean is equal to the sum total, which was 70 plus 62 plus, and we added up to the 58, and we divided by 7. And the sum for that was 448, the total for that. Divided by 7, we got 64%. And then we summed up and said this learner had an average or a mean mark of 64%. And then we also looked at a problem where you needed to find a missing value. This time you have the mean. You're not calculating the mean. The mean is already calculated for you. All you need to do now is to say, what is this missing value that I need to calculate? For example, take the same scores that we had there, but there's one value that is missing. If you're very clever, you could see which value is missing, but I won't tell you. Let's add the rest of the scores. We said we're going to add LO plus the 70, the 62, the 54, up to 58. And then we divide this by 7. And we say the answer is given to us as 64. So we know already the mean mark. But there's one subject that we don't know the score. And we're going to add the rest of the marks. And if we add the rest of the marks, we got 366. So we have LO plus 366 divided by 7 equals to 64. And we said, let's look at how we can reverse this, because we have divided there by 7. For us to reverse division, we need to multiply. We said we multiply both sides by 7. And once we do that, we will have this 7 cancelled, and 7 times 64 will give you the 448. So it's going to be LO plus the 366 equals to 448. And then we are missing the LO mark, so we'll then reverse the addition and take the 366 to the other side. When we do that, we change the sign. So it's going to be minus 366. And the answer is 82. So the LO mark was 82%. So that's the missing value. Now, they love these questions. If you check this year's paper, the matric paper just written a few days ago, a few weeks rather, the table below shows the full storage capacity and dam levels as a percentage of the full storage capacity in different provinces in South Africa. You should know there should be how many? 9 provinces. So we should be having 9 values that we are going to have. But there we are on one of the columns here. We are missing 2 values. We are missing 2 values. And there was a question on that. You needed to find the value of D. So the question says calculate the missing value D if the mean percentage storage capacity for last week was 83. So the key words that we're looking for is last week. This is what you do when you are using tables and you are interpreting questions and you are finding answers from a table. The first column there says province. The next one is net FSC, million cubic meters. And then the next one is this week. The next one says last week. And the next one says last year. And our question says last week. So we are going to use last week's data values. So we need to use these values on this column. I'm going to give you some time to do this, but I will just guide you now and then give you time to do it. So what needs to be done here, we need to add the rest of the scores. So the 99, the 101, the 73, 88, 89, 82, 105. And, you know, little maths, D plus D, that's algebra, it's 2D. Remember, our subject is mathematical literacy. It's maths before you do the literacy part. The literacy part is reading and writing, but there is maths component there, which is not huge, but it needs to be done properly. So you need to add the D and the D. You will get 2D. And you add the rest of the numbers, and then you divide, like I did the other one, by 9, and the answer must be equals to 83. So you know what I want you to do? I want you to attempt this question. I'll come back and show you how it's done. Sure, 2 minutes is enough. This question is about 3 marks, or 3 marks. So you can do this in 2 minutes. I'll give you 2 minutes. After 2 minutes, I'll come back and show you how I did this question, but I've guided you. I hope you'll be able to do it. And please send a question on 082760 2630. That's our WhatsApp line. If you have any question, send that question through that WhatsApp line. We'll try to answer as best as we can your questions. Thank you very much. See you after 2 minutes. You must do this question. 2 minutes. Thank you.
You have been given power to decide whether you want good results in your life, in your schoolwork, or you want bad results. As Tony Robbins said, it is in the moment of your decision that your destiny is shaped. And your destiny is shaped right now with the decisions that you are currently making in your schoolwork. So decide whether you want to be an A student and start working on it, because there is power inside of you. The infinite power is inside of you, and the time you decide to tap in that power, you will become who you want to become in your schoolwork.
Dreams. What is your dream? Yini phupho lakho? Not your parents' dreams, not your mom's dream for your life. What is your dream? Is it to get a bursary? Is it to study science? Is it to become a DJ? Is it to become a singer? What is your dream? Iphupho lakho. Once you have that dream, what I need you to do, I need you to write it down. Ingole mofati. Write it down, ibhale phansi, and read it each and every single day when you wake up. Read it each and every single day before you go to bed, and remind yourself of where you want to see yourself. What is your dream? Write it down, meditate on it, and go after it with everything that you have. Excellent. Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you are gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence.
Attempted this question. So like I advised you, you need to first add the D's. So we'll say D plus D. And I'm choosing D plus D because those are like terms. They are the same. And then I'll say 99 plus 101 plus, you can do this on your calculator, plus the last number, which is 105. I hope I have space here. And this will be equals to, in fact, before we say equals to, we need to divide this, because remember we're calculating the mean. So we need to remember the concept that we need to look at. It says calculate the missing value D if the mean. So we are given the mean. So I'll divide this by 9 because there are 9 values here, 9 numbers. Remember my total, and divided by number of my numbers. In fact, number of my scores. And I will say this equals to 83. I hope that 105 is clear. But you know, D plus D is 2D, right? And plus, if I add all those numbers, I hope you did add them, you get 637. Now, like we did in the previous question, we'll divide this by 9 equals to 83. Now, we want this 9 over to the other side. So I will say 2D plus 637. So I'll multiply both sides by 9. So 9 times 83. I hope you'll understand where I'm coming from. So it's 2D plus 637 equals to 83 times 9. I've got my calculator here. It gives me 747. So my answer is 747. And therefore, I'll take it up to here then. Then my 2D is equals to 747 minus the 637. So if I subtract 747 minus 637, I get 110. So I'm getting 110. So my 2D is equals to 110. Now, I want D. I don't want the 2. So the 2 is multiplying the D. I'll do the opposite or the inverse of that operation. I'll divide by 2, both sides. So my D is equals to 55. I hope you also got 55. Now let's go to the next question. Next question. We now still on the measures of central tendency, but we're looking at the median. Now, what is a median? Median is a middle value. As you can see, median, it rhymes very well with middle value. So it's the most middle value. So in other words, you have to arrange your values in ascending order. Ascending order means you're going up. You're starting from the smallest and you're going up to the largest. So as you can see, these numbers here are not arranged in any order. You're starting with 70, 82, 62, 54, 60, 62, and 58. There are 7 subjects there. So we have to start with the smallest value. And what is the smallest value there? The smallest value I see there is 58. So I'll start with, 54. Then next is 58. So I've got 58. I'm arranging in order. It's very important that you arrange your numbers in order. Don't assume the numbers are in order, but because otherwise you get a wrong median there. So that's 58, and the next value is a 60, and the next value is 262s. Don't think by writing one of the 62s you have represented all of them. No, you have to write even the repeated numbers, repeat them. And the next one is a 70. And lastly, we have an 82. I have to check if I have 7 numbers there. 1, 2, 3, 4, 5, 6, 7. I have written those numbers in ascending order. That means I started with the smallest and I've ended with the maximum or with the largest. And now, then I can determine my median. Some people do it like this. They go 1, 1. They go 1, 1. They go 1, 1. And this is the middle number. So my median is this number. So my median is actually 62. Check. I have 3 numbers on the right hand side of this number, and I have 3 numbers on the other side. So the median for this data is actually 62. So if you didn't arrange these numbers, your median was going to be 54, which is wrong, because these numbers are not in ascending order. Now, let's look at a case where we have, these are an odd number of numbers there. Let's look at a case where you have even numbers. How then do you do when your numbers are not 7, 9, they're even? How do you do that? For example, a learner wrote 6 subjects and got these marks. So now you'll see that we have only 6 marks there. We'll do the same. Start with the lowest number, 54. I cross it out. And the next number is 58. And the next number is 60. And I repeat my 62s. Right, 2 of them. And my last number is a 70. So there we are. We've got those 6 numbers. So now, if we do that idea of saying we start from the end and we go in, we'll have a problem here, because we say 1, 2, 3, 1, 2, 3. The middle value is found here. It's not part of the numbers, but it's there. Hypothetically speaking, it's there. We're saying it's somewhere there. So we are going to then find the middle ground, because the median is not part of the numbers. This is one disadvantage. I'll talk about the disadvantages of each of these measures of central tendency. The median is sometimes not part of the numbers. So the median here is then between 60 and 62. So we'll then find the average of these. So we're going to say, okay, 60 plus 62 divided by 2. And now, when you are working out on your calculator grade 11s, I want to caution you, don't go on your calculator 60 plus 62, then divided by 2. Your calculator will give you a value that is not between 60 and 62, because your median is between. So in other words, the value that you want is between 60 and 62. So you would rather use the fraction key of your calculator and add first and use brackets. 60 plus 62, you get that value and then divide by 2. The answer there is 61. As you can see, 61 is between 60 and 62. I hope you remember the 2 methods, or the 2 ways, 2 cases where you need to calculate the median. You calculate the median with an even number of scores, or with an odd number of scores. So when you've got an odd number of scores, you've got a clear-cut median. You've got a median which is part of the numbers. But when you've got an even number of scores, the median is not part of the numbers. So then you need to take the 2 middle values, add them, then you divide by 2. So in other words, you're finding the middle ground. Like we're saying, this is a median. It is the median as a middle value of the ordered. The key word there is it must be ordered. You can't just take any numbers and find the median. The numbers must be ranked. They must be ordered. They must be in an ascending order. Now we move on to the next one. And the next one is the mode. So we've done the mean, median, and now we're doing the mode. The mode, most, mode, most. So if you think of mode, always think of the word most. If you think of median, always think of middle, then you'll get it right. So the data value that occurs the most, we don't calculate the mode, by the way. So we determine the mode. We observe it from our data set. We look at the numbers and we see, oh, this one appears the most and most frequently. So that's how we get it. So what is very useful with the mode is that we can do that with numerical or even categorical. Remember the data types or the classification that we made. We said our data is divided into two. It's numerical or categorical. And when we say categorical, remember what we said? It exists in words. In words, description. We are describing your favorite team, your favorite car, a lot of other things. Those are not in numerical value, but they are categorical value. They are in words, they are in description. Then numerical, we talked about discrete and categorical. So now, not categorical rather, but numerical, we talked about discrete and continuous. Yes. Let me correct that. And we are going to look at these values now. You have obtained the following results for 6 subjects. And this is 70, 62, 54, 60, 62, and you have 58. So the question is determine. You remember I said we don't calculate. The question will always say find, determine. It will not say calculate the mode. If somebody says calculate the mode, then it's something else. It's not going to be done in listed values. No, we won't ask you to do that. So if you see the 62 appears twice, every other number appears once. So our mode is therefore 62%. Now, you can have more than one mode or no mode at all. So I want to caution you on that. You can have no mode or you can have more than one. And that data will be having a lot of values that are repeated the same number of times. Or all the numbers are only repeated once and therefore there is no mode. So we don't force that to happen. Now, I want us to look at a case where we have 2 girls that are playing netball, right? And they played 7 games. And we want to see, assess their performance, to check who performed better, who is a better player here. So we're going to use the measures of central tendency. I want you to do the first part, the A part, then I'll join you on the B, because on the B, I want to discuss this very, very deeply to say how do you determine who is a better player. So what I want from you now in the next 5 minutes or so, I want you to do the measures of central tendency. So I want you to find the mean for each data set, for each lady there, for each learner there, or for each player there. You find the mean, you find the mode, you also find the median. So you find the middle value, you find the mode, the one that appears the mode. If there is none, please say none. Don't force matters there. So I want you to find the 3 for both players and list them separately and say this one is for Linda, this one is for Togo. Thereafter, I'll join you where we will say, okay, who is a better player and a reason for saying that. And we give a reason why we say if Togo or Linda is a better player. Why are we saying that? Using the measures of central tendency. I'll give you 5 minutes. So in 5 minutes time, we'll be back. We'll be doing question A and B. I'll check in your answers in question A, and then we'll discuss how we answer question B on who is a better player. Thank you very much. See you after. Please send your questions on 082 760 2630. I'll touch base with you when we come back after 5 minutes. Thank you. Thank you. Welcome back. I hope you did the questions as I instructed you. We will start with Linda. All right. Linda has 3, 7, and all of that. So we have to first arrange. I'll start with the median. I hope you also started with the median. We start with the lowest score here. Linda's lowest score is 2. So I've done the 2. The next one is a 3. The next one is a 5. So 5 comes third. And the next one is a 6. And the next one is a 7. And she also has 11. And the last score is a 29. So those were her scores. So 2, 3, 5, 6, 7, 11, and 26. That makes 20, how many games? 7 games. And therefore, her median, here we don't have a problem because there are odd number of scores here. We have a clear-cut median. So count 1, 2, 3, and we have a 6 there, 1, 2, 3. And there are 3 numbers on your left and 3 numbers on your right. So the median score for Linda was 6. What does that mean? It means half of your scores were 6 or less. Rather, they were less than 6. And half of your scores were more than 6. Now, what about the mode? Let's look at the mode for Linda. Now, look at the modes. 2, 3, 5, 6, 7, 11, 29. There is no number that is repeated, so the mode there is none. Please don't write 0, because once you say the mode is 0, you're suggesting that 0 is part of these numbers. And meanwhile, there is no 0. She scored at least 2 goals on each of those games that she played. Now, we need then to calculate the mean, and we're still doing Linda, remember? So Linda's mean will therefore be 3 plus 7 plus up to the last number, which is a 5, and then divided by 7 games that she played. And if we add those, we get 63 over 7, which will give you 9. So that means on average, when we talk about the mean, she scored 9 goals, right? That's powerful. That's powerful. Let's look at the other player, who is Togo. So I'll write Togo's stats at the bottom here, and I'll start with the median. And the smallest number that I see for Togo is 5 there. And the next number I see that is smaller is a 7. So as I write down the number, I cross it out so that I don't make a mistake. 8, and then the next one is a 9. Then the next one is a 10. And the last 2 numbers are 12 and 12. So that's Linda's scores in ascending order. Very important to know that we have to arrange numbers in ascending order. And like Linda's scores, we have the median as the 4th number, so that we have 3 numbers on the left, 3 numbers on the right. So the median for Togo is actually 9. And the mode, let's look at the mode. What is the mode there? The mode is one number that appears more than once, and that number is a 12. So the mode for Togo is a 12. Remember, we didn't get a mode for Linda because there was no repeated number, and that happens. That should happen in some cases. And don't force it and say there must be a mode. If it's not there, it's not there. Don't come up with something that is not there. Then with the mean, we also do the same. We add the scores, and we say 9 plus 8 plus 12, and we divide these numbers by 7, and we'll get 63 over 7. So now, wait now. These 2 players got the same mean, different median. The other one didn't have a mode. And what are we saying about the question B? So I hope you got these answers. Median for Linda is a 6. The median for for Togo is a 9, and the mode, there is no mode for Linda, but there is a mean of 9 for each of these players. Now, on surface value, one would think, oh, these players performed the same way because they have the same mean, they have the same average. Remember, the three are what we call the averages. They are measures of central tendency. Now, if you look at the scores for Linda, there is one value that is strange there. That is strange. I want us to define that value, and I will come back and define that value. This 29 looks very strange. And why would Linda score 29 goals in game number 3? And she scored 2 in game number 6. But all of a sudden in game 3, she scored 29. And that value then is extremely high. And therefore we would call it an outlier. I'll come back and define it nicely on the next slide. So this is an outlier. It is extremely high. And if you look at the scores for Togo, it's 9, 8, 7, 5, 12, 10, 12. There is consistency there. The values are more or less the same. But if you look at Linda's values, there is just one value out of the blue that becomes very huge than the rest of those scores. Possibly someone will have to investigate what happened in game 3. What team did Linda meet, or somebody recorded those scores wrongly, or something happened. There are many reasons why we have outliers. Maybe somebody who was measuring was wrong, or maybe the team that they played was too weak, and therefore Linda was going all the way and you know, got all those scores, 29. But let's answer the second question. I've already got into answering that question. Who do you think is a better player? I'll go for Togo. Togo, for me, is a better player, and I'll tell you the reason. Togo's median mark is higher, or median score, rather, or median goals that she scored are higher. Median score is higher. That means she is consistent. She is dependable. She is dependable. Maybe let me use that word, dependable. So we can trust her. We can depend on her. But with Togo, in some games, she scores only 2. That means on a day that she's not happy or somebody got her upset, she will score nothing. But we can trust Togo because the median values actually shows us that more than 50%, at least rather 50% of your values are above 9 and 50% are below 9, depending on how you want to look at it. Some people look at the higher side of things and say, okay, more than 50% of scores are more than 9. And that means a lot. That means Togo is consistent. So that's how you answer such a question. Or even you say most of the values there are closer to the 9. And that's why I went for the median, because the rest of your scores are consistent, but with Linda, only game 3 that has got a higher mark. So there's a problem with Linda there. Even if their mean is the same, the median is different. That tells you that you cannot trust the mean all the time. And when does that happen? That you don't trust the mean. I want you to now do question 2. We have done question 1, and we'll come back and say why should we not use the mean all the time. So I want you to do question 2. Here are the monthly salaries of 11 workers at a certain company, and they are written in 1,000 rand. Remember that. So when we say 8, we mean 8,000. When you say 10, we mean 10,000. So I want you to find the mean, median, and mode of these values. And then I want you then to attempt this question where you say, which measure of central tendency best describes this data? I've given you hints there why we say a certain measure of central tendency is the one that best describes your data. Now, remember, the median works when we don't have extreme values very perfectly. And the mean, when we have extreme values, it doesn't work nicely. And sometimes the mode is not there. I'll come back and give you a slide where I summarize what I've just said. So I want you to attempt this question. It will take you around about 3 minutes. 3 minutes will be enough, or 4 minutes, rather 4 minutes. Let me give it 4 minutes, because you need at least 3 minutes to do the mean, median, and mode, and then 1 minute to decide on which measure of central tendency best describes your data. And please don't forget to ask questions on 082 760 2630. I haven't got any question. I don't know. Maybe I am talking above your heads, or I'm explaining very well, but I want to hear some feedback from you. Where you have questions, please ask on 082 760 2630 on WhatsApp. Thank you. Thank you. Welcome back, grade 11. Somebody just asked a question, and Joy Sapo, I'll attempt to answer a question. The question is, would it be wrong to calculate the average to get who is the best player? Now, I want us to go back to that question where I was calculating the averages. If you look at these two players, Joy, Linda and Togo, we did calculate the average. When you say average, I hope I understand you very well. You mean the mean. But if you look at the mean, the two players got a mean average of 9. So that average of 9 doesn't tell us much, because it tells us that they performed the same way, or they are all at the same level. So we need then to dig deeper than that and say, okay, let's look at the other measures of central tendency, the other two. The mode. The mode doesn't tell us anything, because remember, Linda, the mode is none, nothing. She never scored the same score on any 2 games or 3 games or whatever. There is no repeated scores. And if you look at Togo's mode is 12, and therefore we can't compare the two. We can only compare apples with apples now. Mode none there, the mode for Togo is 12. Now, we then need to look at the median, because there is an outlier. On just one game, Linda scored 29. If I were a coach, you know what I'll do? I will work with Linda and put her on a tournament, a short period tournament, because she can do very well on a tournament, or make her a super sub, because on a good day she can score high goals. But Togo for me is dependable. Look at her scores: 9, 8, 7, 5, 12, 10, 12. All the scores can't go below 5, actually even 7, because the least that she scored was on game 4, which was 5. The rest of her scores are actually closer to the median, which is 9. Therefore, we cannot use the average, the mean, in this situation, because there is an outlier. There is an extremely high value. And remember, it can be extremely low as well, which means there is something that we need to look at there. Why 29? So this dismisses the use of the mean. We can't then use the mean because of that number, which actually influences our mean, because our mean is the total of all the values divided by the number of values. So if we use it, the number of where she did very highly, it will influence the average. And that is why if we remove the 29 for Linda, if we remove the 29, she won't get an average of 9. Let's try that and see. So if I remove the 9, the 29, I'll go 63 minus 29. I'll end up with 34. So she scored 34 goals on 6 matches, and only on 1 match scored 29. So that makes her not a best player because of that. She's not consistent. She's not dependable. So if we do the average now of the 6, so 34 divided by 6, you'd see her average is 5.6. So that means her average is about 5 or 6 goals. But if you look at the average for Togo, is actually 9. And that's how you answer that question. I hope you were satisfied with the answer. You actually happy with that answer. I want us to go back to that slide. I want us to go back to that slide where we are looking at our data handling. I want us to go back to that slide. I lost that slide, but I'll get now to that slide. We were here comparing Linda and Togo. So I want us to go back to that slide and now move on to the next one. We did this one. Now I want us to look at these answers that you did. I gave you this as your activity. Now, the monthly salaries of 11 workers at a certain company are shown below in 1,000 rands. The question that I asked you to do is calculate the mean, the median, and the mode. Now, if you want to calculate the mean, it's very easy. You'd say the mean is 8 plus 10 plus 28 plus 28 until the last value there. And there are 11 workers. So that means 1, 2, 3, 4. We'll divide this number or the total by 11. And I hope you got this answer as much as I got the same answer. It was 360 divided by 11. And this answer is 32,7272. Right. So remember, these are in 1,000 rand. I can leave that answer as it is, like that. And then we go on to do the median. Remember, when we're finding the median, we have to arrange the numbers in order. So the first number that is small there is 8. The next one is a 10. Okay. And the next one is another 10. And the other one is a 15. The next one is a 16. And the next one is a 28. Two of them. 28, 28. And the next one is a 31. Yes, I've got 31. And then the next one is a 37. So 37 and 46. And finally, I have 131. So my numbers are now arranged in order, and therefore we can now calculate the median. It's easy for us to find the median in these values because there are 11 workers. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the median is the 28 because that's the one that is in the middle. I'll have 5 numbers before it and 5 numbers after it. And I hope that's what you got. If you want to write these with the rand sign, that will be 28,000. Remember, it's 28,000 rand. Or you can leave it as 28. We all know what is going on there. And this one you'll have to multiply by 1,000 and get it to 32,727 and 27 cents. That will be your values. So that's the median. And now the mode. Remember what I said about the mode? You don't actually calculate the mode. You observe it. So we have to look at the values here. The tens are repeated. So then the mode is 10. If you want, you can say it's 10,000 rands. So it's 10,000 rands. So those are your values. The measures of central tendency, 3 of them, the mean, the median, and the mode. Now, let's do the part B of this question to say which of the 3. Now, the mode, there are 2 modes. Somebody is reminding me there are 2 modes there. There's 10 and there are 28. There are 2 modes. So it's a bi-model, meaning it's got 2 modes. Now, let's look at the last question there. Which measure of central tendency best describes this data? Our decision is based on the numbers that we have there. So we look at each of these values and check with the values that we have here. Now, if we look at these values here, there is one value that appears to be out of place, and that value is 131. And therefore, I will not go for the mean, because the mean is influenced by the extreme values, that 131. So I'll go for the median in this case. So every time grade 11s, you've got an extreme value, make sure you use your median as your rep for the values. It's good rep. It best describes your data. So for me, I would say the median best describes our data. And the reason is because we have an outlier. The data contains an extreme value, right? You can put it like that, or you can say it contains an outlier. So that is why the median best describes this data. Otherwise, most of the values are closer to this. Most of the values are closer to this value. So that is why we're choosing the median. Otherwise, we can't use the mode, because look at it, there are two modes already there, 10 and 28. Which one do we choose? And there is the mean is affected by this value, the 131. So therefore, our decision is there, says that the measure of central tendency that we can use there is actually the median. Now I want us to move on to the next part of our lesson. And we are looking at, this is what I was talking about. I'm summarizing now. When to use the mean, the median, and the mode. So you must know when to use the most suitable one. For example, you have 70, 62, 54, 60, and there you are, you've got 8. And you're wondering, where did the 8 come from? Because the rest of the scores are actually above 50, 54, 58, and there you are, you've got an 8%. What happened here? Why do we have an 8%? So the 8% is an outlier in this situation. It's an odd one out. It's an extreme value. So in other words, it's an extremely low value or extremely high value. In this case, it's an extremely low value. So that is why we call it an outlier. The value in the data set that is far away from others. So that's why I say it is an odd one out. The mean is the best used when your data doesn't have any outliers. And the median is used if we have outliers. So if their data set has an outlier, we can use the median, because the median looks at the middle values. It ignores the end values. That means those extremely low or extremely high. And the mode is best used for categorical data, because remember, we cannot arrange favorite teams or whatever and then we choose the one that is in the middle, or do the calculation or add the teams and divide. We can't do that. We can't divide colors. Remember, that type of data is categorical. But we can use it even in that situation. The mode can be used in that situation. We can say the most popular team, the most popular pair of shoes in a class is size 5, is size 8, or whatever. Then we have what we call a mode. So a mode can be also used even if your data is discrete. Remember, the size of pair of shoes is discrete. So you can use it on categorical data, or even on discrete data, even on continuous data. Now, I want us to then summarize. This captures it very well. I hope you're going to take a picture of these and look at the advantages and disadvantages of each of the measures of central tendency. Mean, useful for comparing set of data, like what Nhlapo was actually asking me to say, which one, why can't we just calculate the average? It's easy to calculate the mean. The mean, you just take the numbers, add them, divide by how many there are. There you get your mean. And it's easy to do that. You can use it even when you have continuous data. But don't forget this. The mean is affected. Someone say often affected, very much, by outliers. So if you have extreme values, your mean is affected by those extreme values. Right. But the median, on the other hand, the advantage of median is that it is not affected by the outlier. It stands in the middle. No outlier affects the median. That is why we chose to use the median when we're comparing those two, Togo and Linda, because if you check, Linda scored one big score in one game, that was 29 goals. But the rest of the scores were actually below 7, below 8, and all of that. If you check, the Togo scores were all consistent. And the disadvantage now, the values need to be ordered. Sometimes we forget, we just take the values as they are. There we are, we look for the median. And it can't be used for categorical data. You can't arrange teams and then say this one is the most middle. Who says this one must start and what? It's not a log. When we say how many people support this, what's the most favorite team, you can't do that. You can't find the median on categorical data. Now, the mode. The mode is not affected by outliers because it is the most popular score or the one that appears the most. And it can be used for both categorical, and numerical data. That's the advantage. You'll hear somebody says the most favorite drink in school is orange drink. Or in fact, on average, most learners in this school buy orange drink. And that means that person is talking about the mode, but is using the word average. Remember, I said to you, all of these are called averages. They are measures of central tendencies. Now, if there are no repeat, that's the problem now with mode. You would have seen in one of my examples, there was no repeat and therefore no interpretation of the data. What do we say? Because remember, we had one learner there, one player without the mode. And what do we say about it? Well, how do we interpret that? We can't say anything. So those are the disadvantages. Now, I want us to move to the next part where we look at the measures of spread. So the measures of spread, this is the last part, are sometimes called the measures of dispersion. So we're looking at how dispersed is our data, how spread out is our data, how wide is our data, what is happening in our data. That's an indicator. I know you know this one. You do the measures of central tendency using the range. So you use the range. The range tells you which value is higher, which one is lower. In fact, the range is maximum minus your minimum. I'll come back to that. We'll give you an example later on how we calculate that. So the difference between the highest value and the lowest value is your range. If the range is small, that means the data is clustered together. In other words, the data is closely knit. The values differ by small margins. They differ with the small values. If the range is large, then the data is far apart. Now, for example, we're looking at Jabu there and Kelly's results. So if we look at the range of Jabu's results, look at them. They are already written in order: 60, 63, 68, 72. So the range for Jabu will be then 77 minus 60, which means it's 17%. That's Jabu. Now, let's look at Kelly. Now, Kelly's range will therefore be 71 minus 64%, which will give you how much? It will give you 71 minus 64. The range for Kelly is 7%. Now, you can already see that the scores for Jabu differ slightly than, in fact, the scores for Kelly differ slightly than those for Jabu. Jabu scores, the highest is 77 and the lowest is 60. So the difference is 17%. But with the Kelly's marks, the difference is just 7%. So the marks are close to each other. That means there is no variety in the marks when it comes to Kelly. But when you look at Jabu's marks, there is a huge, huge difference between the marks. But all the same, if you look at the two students, they did well, 70, 60. There is no mark below 60. In fact, there is no mark below 50. All of them did very well. Now, I want to then look at the quartiles. Now, quartiles will be a new thing to you, grade 11s, and we need to define it nicely, and I'm going to use a diagram to define that. So when you say quarter, quarter means 4, quarter means 4. So if we are looking at quarters, we divide a list of numbers into quarters. In other words, into 4 groups. So the very important thing that you mustn't forget is, as much as you do the median, it must be that your numbers are in order. Now, if your numbers are in order, you always start with the middle value. I will call it Q2, which is the second quarter. If you do your maths very well, if you say it's second quarter, that's 2 divided by 4. That's second quarter, 2 over 4. That gives you 0.5 or half. So that tells you that this is actually your median. So your median is actually your Q2. And then You'll then look at the first half of your data, and that will give you your Q1, which is the first quartile. I will explain that more using an example with some numbers. Then you look at the last set of numbers, the last half, and the middle of that is your Q3. So those are your quartiles. And this value that is here will be your minimum value. Remember, we arranged our numbers in order, and this last value will be your max, your maximum value. So I will give you an example and then give you some questions where I will ask you to calculate the quartiles and all of that. So now we have a concept. This is the concept that we actually looking at. When we say Q1, this is the set of data represented by the point that is 75% of the values are more than that. I'll take you back to that. If you look at this one, we have 25, 25, 25, and 25. So the Q1 stands here, which means there is 75% of the values above it because it's standing at 25%. And on the other side, 25% are below. And if you come to Q2, Q2 is a glass that is half empty or half full. So it depends on what you want to see. If you want to see the high end of this, you're saying 50% is above. And if you want to see the other side, you're saying the other side 50% is below. So that's why I said half empty or half full, depending on your view of life. If you want to see half full, you're actually looking at the highest values, you're looking at the higher end. You're saying the median stands in the middle and 50% of the values are above. And if you want to look at the other side, you're saying 50% are below. Then we come to Q3. So when you are here at Q3, 75% are below. As you can see, it's 25, 25, 25. That's 75. And only 25% are above. There are cases where you want to be in Q3. There are cases where you would not want to be in Q3. If we are talking about maybe your marks in class and you have your mark that is Q3, so it means you are better than 75% of your learners in your class. And only 25% are above you. That is on marks. But if it's about weight and you are heavy and you are in the Q3 in terms of your weight, so it means you are heavier than 75% of people that are of your age. And I wouldn't want to be in that situation. So I'll come back to this, and I've written it down there nicely. Then we come to a situation where we call this thing, we call it IQR. Simple, it means interquartile range. That is Q3 minus Q1. Now I'll give you an example quickly, and then ask you to do some questions, and that will be about 5 minutes or 10 minutes for you. Now, here is an example. Consider the marks obtained by 14 learners in a mathematical literacy exam, 40, 60, 65, up to 100. If you check, these numbers are already arranged in order. If they were not arranged in order, you then start from scratch, arrange them in order. So the question is, we want to calculate our quartiles, Q1, Q2, and Q3. Lower quartile, median, and upper quartile. I want you to remember those words. So when we say Q1, we say it's the lower quartile. Lower quartile. In other words, it's at 25%. And then when we say Q2, we mean it is the median, the middle value. And then Q3, it is the upper quartile. So I want to do those using this specific question. Now, there are 14 learners. So that means we have a bit of a problem because we don't have a clear-cut value. If there were 15, we're going to have. So 40, 60, 65, 65, 68, 69. And I've counted 1, 2, 3, 4, 5, 6, 7. Right? 1, 2, 3, 4, 5, 6, 7. So I have 7 numbers on my left and 7 numbers on my right. So my Q2 then, you always start with Q2, is 70 plus 72 divided by 2. That will give you 71. Right. And then your Q1, you now look at the first half. Right. You're looking at the first half. Remember, our median here is not part of the numbers. So therefore, our median is somewhere here. But the 70, 69, 68, up to down, going down to 40 is part of my first half. So it means I have 7 numbers in my first half. And therefore, this is now nice because our median is going to be clear for the first half. 1, 2, 3. 1, 2, 3 on the other side. So Q1 is my 65. I have 3 numbers before the Q1. I have 3 numbers after that Q1. So my lower quartile is actually 65. What does that mean? It means 25 of the numbers or the scores or the exam marks are less than or equals to 65. And on the other side, you're looking at 75% more than the 65. Now, look at the second half. 1, 2, 3. And this is my Q3. 1, 2, 3. So my Q3 is actually 76. So those are my quartiles. Now, when I do the interquartiles, that become very easy. It becomes child's play because if you have those numbers, you just take your calculator and calculate. So it is a range, remember? But what type of a range? Interquartile. That means Q3 minus Q1. What is happening with this range? I'm actually looking at the middle values. I'm ignoring my extreme values, my outliers, and I'm now concentrating on the middle values. And I'll say it's going to be 76 minus 65. That gives you 11. So that's my interquartile range. So if somebody were to ask you to comment on the results of the 14 learners, there's numerous comments that you can come up with, a lot. So you can talk about Q1, you can talk about Q2, you can talk about Q3, you can talk about the interquartile range. So I'm just going to pick on one and hope that you will do the rest. I'll pick on the Q1. So what does that mean? That means 75% of the learners, right, got above this Q1. What is my Q1? 65%. And that's a lovely class. That means this class performed very well, and I hope you also did very well. So that means 75% of the learners got above 65%. Remember what I said? You can write a lot there. One could have just picked up the lower end and say 25% of the learners got less than 65%. This is where politicians come in and they abuse stats. This is where you can abuse stats if you choose to look at the bad side and ignore the good side. I'm choosing the positive side. 75% of the learners got above 65. And if you used Q3, you could say the same. You'd say 25% got above 76, and 75% of the learners got at least or below 76. Now, I've done this activity for you, and I'm expecting you to do the next activity, and that could be the last activity that we're doing. I'm going to give you a minute to arrange these numbers. This is taken from some sources where we have fatalities there. It says the data alongside was released on fatal accident for April 2017, 8/27 and the like for each of the provinces that we have there. Use the given data to determine the 5-number summary. Now, what we mean by 5-number summary, we want the minimum, we want Q1, you now know what Q1 is, we want Q2, we want Q3, and we want the max, which is the maximum, right? So we're going to determine those values. Now, I'm going to give you a minute to do the first thing, which is arrange the numbers in ascending order. I will touch base with you after 1 minute. Remember to touch base with us. Hit us on 082-760-2630. Thank you very much. Thank you. Welcome back. I hope you arranged these numbers the way I also did. I started with the 8 there, and the next smallest number is a 12. So we're going up. Remember, we're saying ascending. So ascend is to go up. So we have 12 there, and the next number is a 22. So there is 22, and the next number is a 27. Yes, 27. And the next number is 28 and 28. So we have two 28s. Remember, we said we list all of them. We don't say, oh, just because I've got 28, that represents all the 28s. No. So the next number is a 30. The next number is a 38. And we have this number, I don't know for what reason, it's there, 59. All the other numbers are below 50. Now, I will check if all my numbers are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 numbers, 9 provinces. So all of them represented and in ascending order from the smallest to the biggest. And then when we get to the next part now, where we are saying, okay, we've got those values, and now we want to do the quartiles. Now, what's the question? The next question is determine the maximum and the minimum. So the maximum, we all saw, it's a 59, because our numbers, remember, are now arranged in order. All right, I wanted to go back there, but I'll come back. Right, the 59. And the smallest is 8. So the minimum is 8, and the maximum is 59. So those are our two values. So you can see that our data now has a minimum of 8 and a maximum of 59. So that's our first part of the 5-number summary, the two values. Now, these will not tell us a lot because they just tell us the lowest was 8 and 59. 8 people died through accident in April 2017 in one of the provinces, and the highest was 59. Now, then we get into the middle of the data now. The question is, determine the median. Remember, with our numbers is 8, 12, 28, 27 first. 27, I have to delete that. Okay, I'll delete that. 27, put 27. Right, doesn't want to do that. I'll just write it like that, 28 and then 28. And I have 30 and 38 and 59. Now, there are 9 values, nice, because if we have 9, we have a clear-cut median. Because if we have even numbers, we have to find the middle ground. Then the two numbers that are in the middle, we add them, divide by 2. So we look at this, 1, 2, 3, 4, and 1, 2, 3, 4. So what number did I miss? I missed 22, I can see. Right, maybe I should go back to that or start afresh here and give you the values nicely. 8, 12, 22, and 27, 28, 28. These are fresh now because the other ones were mixed up. 38 and 59. Now, 1, 2, 3, 4, right? 1, 2, 3, 4. So your median is actually this 28. So that means half of these values were less than 28 and half were more than 28. Then the lower quartile and the upper quartile. I'm now going to look at the middle values here, the middle value here of the first half. Now, I have a problem now because there are 4. The median is this one. So I'll go 1, 2, 1, 2. And then I'll go for the upper quartile as well. 1, 2, and 1, 2. So my Q1, which is my lower quartile, is going to be 12 plus 22 divided by 2, which is 34, divided by 2, which is 17. And my upper quartile is therefore 30 plus 38 divided by 2, and that will give me 34. And the last question there, determine the IQR. We now know what IQR means, interquartile range. Don't be fooled by the word range. The range is of the quartiles. The highest quartile is the upper quartile. The lowest quartile is the lower quartile. So it's Q3 minus Q1. That's why we call it the interquartile. We are going in the middle and looking for the range in the middle. We are ignoring the lower values and the upper values. So Q3, which is 34, minus 17, and that gives me 17. So the interquartile range is therefore 17. Now, we have done that part, and I will start on this one in our next lesson, where we are finding the interquartile range, or rather, in the next 2 minutes I can do this, and where we find the Q1, Q2, Q3. Now, this is the exam results out of 100 of a group of girls and boys. There is girl power, boy power. I don't know who will win here. And we are saying the marks are already arranged from the lowest to the highest. In other words, this value here is the minimum, and this value here is already the maximum. So we don't need to arrange these values. So therefore, we just look at the values and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 values, and therefore we don't have a clear-cut median. The median is going to be between the 8th number and the 9th number. So we go 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So our median there is going to be 61 plus 64 divided by 2. And that will give you how much? It's going to be 62.5. That's the middle value there. And then you now have 8 values for the first half, which is 1, 2, 3, 4. 1, 2, 3, 4. So your Q1 for the girls is actually 46 plus 49 divided by 2, which will give you, I did this one, 47.5. Then the Q3. Right, Q3. 1, 2, 3, 4. 1, 2, 3, 4. So your Q3 is between 70 and 72. So you add 70 and 72, and then divide by 2, you get 71. So those will be your interquartile range, not interquartile range, the quartiles for the girls. And for the boys, we'll do the same. So having the advantage of doing the other one, we just go in here, and then the Q2 for boys will be 55 plus 57 divided by 2, which will give you, I did that one, 56. And the Q1 for boys will be 45 plus 49 divided by 2, which will give you a 47. And then the Q3, which will be 73 plus 76 divided by 2, and the answer is 74.5. And that answers the first part. Now, when we are asked then to compare the results using the interquartile ranges, so with the values, so we need to then say the IQR for boys is 71 minus 47.5, which will give you 8.5. That's for girls. And then for boys, the same thing. We subtract, and we're going to get 18.5. If you look at the two, the boys are more, they're not consistent, but the girls are more consistent because their IQR is 85. So the middle values for girls differ in small margins. They differ by 8.5. So the performance, now it's not about the highest value here. If you check, that means the values for boys are much, much different. In other words, they are not consistent, because when we measure performance, we want consistency. So I would say the girls have done better because they are more consistent. They are more consistent. I have no space there, consistent, right? I'll explain this more when we meet next time. And that's how you will analyze using the interquartile range. I hope you got something out of this lesson, and that marks the end of the lesson. I hope you would watch next time. Thank you for watching this lesson. Please remember to sanitize, wear your mask, maintain social distancing, and keep safe. See you next time. That's goodbye from me, Mr. Sbanda. Thank you very much.